Well, I'm now at the next stage of experimenting with my capacitively loaded vertical ground plane experiment. So at this stage of the experiment is where I have completely eliminated the remote tuning system. So there's no DC bias T, no magnetic remote tuning system at the antenna at all. And I'm depending now on using an ATU at the station. Now, hypothetically or theoretically, I had a suspicion that I wouldn't really be suffering coaxial losses even if there was a high SWR. And I know that sounds counterintuitive, but based on the way the antenna is configured and how it feeds, it's actually configured at the end of the line as if it's no load. And what I really need at the end of the line is the voltage. What I need at the start of that antenna is peak-to-peak voltages to be high. And so if it's like an open circuit at the end, and I use an ATU, of course the center pin on the coax will be presenting high voltages, and that's what's feeding the unusual coil arrangement, which then drives my elements. So right now, I've only just done this change. I'm running 10 watts on the IC705 there, 100%. And it's running into VK5 there. And we've got a good solid S7. So, in my books, I've already got my answer. I'm running good efficiency. Especially given the conditions right now. Looking at the HAP chart, the destination station is anywhere from the dark green to the light green, which is 8 to 10 megahertz. So it's pretty good, not necessarily optimum, but pretty good because I've got a low TOA, and the signal is pretty good. So I'll be checking on 80 meters and in different locations, of course. But another advantage to me not having the magnetic tuning system up at the antenna is that it now opens it up to the higher bands, because the configuration of the magnetic tuning system also acted as a low pass filter and prevented the pass of the higher bands, and the tuner didn't have a wide enough range to bring in the higher bands. But of course, using a nice old tuner like this at the station, I can bring in the higher bands. I have added, at the feed, after the choke where it goes to connect to the vertical element, I actually have just over a 2 meter run of coax, and that the shield section of that coax acts like a short radial, which is close enough to a quarter wave on 10 or 11 meters. And amazingly enough, when I go to 10 meters, the SWR is not great, but it's within range. And of course, I could always fiddle with this and add different elements, different radials, because the key thing is the vertical element is high Z, and it creates a very large back EMF, and that's what drives the radials. And I could actually have multiple different length radials to make it a multi-band antenna without the need for a tuner, but I think just having the tuner makes it using the tuner makes it a very dexterous, is that the word, diverse antenna. So it's doing very, very nice into VK5. I'll have a very quick jump around. It's very good to see. I haven't actually jumped around yet, so you're kind of witnessing this as I discover it. Apart from me just starting there at VK5 prior to starting the recording. So let's see, I'll just bring that across. So this is into Ararat in central western Victoria. Yeah, and she's doing nearly an S9 there. Yeah, very close to an S9. So yeah, look, it's definitely banging out there. Now, is it radiating on the coax? Well, let's have a look. This is the transmission line. I'll rest on the line. Nothing. the coax is not active. I do have pretty severe choking, so I'd be surprised if there was any activity on the coax. So yeah, fantastic there. So yeah, it's doing a very nice job. So that proves it to me. Now, you may wonder, like, how on earth can I say that with a high SWR that I'm not really suffering coaxial loss? And my argument is that the coaxial loss, when there's a mismatch, the coaxial loss incurred is a loss of power transfer. But the way that I have this set up, it's not designed based on power transfer. This is a voltage-driven antenna, and I'm not requiring a complete circuit. And so, provided the very end of the center pin of the coax, where it connects to the vertical section of the antenna, is getting to its highest peak-to-peak voltages, that's what I need. That then creates a back EMF, which tries to come down the coax, but I've got very heavy choking, prevents it from coming down the coax. It only has one way to go, and that's onto the radial system. 7.3, and thanks for watching.